Right, so as promised, a couple of standard deviation questions that we're going to work through right the way through together. And I've just taken these from the last couple of years' exams, so I wasn't creative enough to think of them, I've just stolen them from them. So this is the kind of thing that you can expect to be asked. So, a bit of a story here. Farmers market took place on the weekend, blah blah blah. Stallholders were asked to record the number of customers were there. A, calculate mean and standard deviation of the number of customers. So mean and standard deviation is what I want. So first thing I'm doing is I'm going to draw out, start my table with x and x squared. Okay, remembering that when I'm coming to do this, my mean is my sum of x over n, and my standard deviation is the sum of x squared minus the sum of x all squared over n, all over n minus 1. All of that is in the square root. So that's the formula I'm using. I'm not going to use the other one. I don't like to use the other one, but you're welcome to give it a go if you want. So the first thing I'm going to do is put my numbers into my table. So I've got 120, 126, 125, 131, 130, and 124. So just out of habit now, the next thing I'm going to do is I'm going to square each of those numbers. So I've got 1, 4, 4, 0, 0. 126 squared is 1, 5, 8, 7, 6. 125 squared is 1, 5, 6, 2, 5, 3, 1 squared is 1, 7, 1, 6, 1. 130 squared is 1, 6, 900. 20 squared is 1, 5, 3, 7, 6. And what I'm going to do now is I'm going to add up both of my columns. So I've got that plus 1, 6, 900 plus 1, 7, 1, 6, 1 plus 1, 5, 6, 2, 5 plus 1, 5, 8, 7, 6 plus 1, 4, 4, 0, 0. And that gives me here 9, 5, 3, 3, 8. So 95,338. I'm going to add up my other column, so I got 120 plus 126 plus 125 plus 131 plus 130 plus 124, and there that gives me 756. So just for reference, what is it we worked out? Well, here in my left hand column, that is my sum of x, right hand column, my sum of x squared. So starting to answer the question then, my average, my x bar, is the sum of x divided by n. So I've got 756 divided by how many things there are, and there are 6 of them. So again, we can either count them, or we can be looking at questions and it tells us there in the question that there were 6 of them. So we're going to do 756 divided by 6, and that gives us 126 out. That's my mean. Next thing I'm going to do is I'm going to put my numbers into my formula to find my standard deviation. So far I've got my mean, I need to get the standard deviation. So my sum of x squared is 95,338 minus the sum of x is 756 all squared divided by n, which in this case is 6, all over 6 minus 1, and that is all under my square root. So the first thing we're going to look to do when we are solving these, I got a pen, is I want to sort that bit out first. That's the messiest bit. So I want to find what 756 squared is divided by 6. So 756 squared is 571,536 divided by 6 is 95,256. So again, when we're doing this as our check, I'm coming to put my numbers in. So I've still got 95,338 minus this new number now of 95,256 all over 5. Now these two numbers on the top should be similar. Okay, they should be of about the same size, and the number that comes first should be bigger. And so I'm looking at my numbers there, and they do in fact make that, right? And those conditions work, and so I'm happy with what I've got there. So at this point I can stick this into my calculator. I can do 95,338 minus 95,256 all over 5, and all of that's in the square root, and that gives me a standard deviation of 4.049. And the number continues, and I'm going back to check, did it ask for it rounded to a certain number? No, it doesn't. So we are going to just keep it there as 4.0, rounds up, 4.05. That's what we'll do. So there is our standard deviation. The next thing it asks, though, is it asks us to make 2 valid comments comparing the number of customers who visited these stalls on a Saturday and a Sunday. And so what we're doing is we need to compare our means, and we need to compare our standard deviation. So a quick think. The first time when we did them, our first set of results, well, what did we get? We got 126 as my mean, and we get 4.05 as the standard deviation. Looking at these new results, I've got 117 as the mean, and I get 6.2. That's my standard deviation. So that was my second go round. Okay, and so what we can say is from the first sample, the average number of customers was higher, and as the standard deviation was lower, because my 4.05 is less than 6.2, the numbers more or less, I'll say spread out, but we'll spell that right. More or less spread out. So I've got a comment on my average, I've got a comment on my spread. Okay, so let's try another one then. So again, there's another story, Jenica's problems with his internet, blah blah blah. What it wants is it wants the mean, and it wants the standard deviation. So the first thing again, I'm drawing out a table for x and x squared. Sticking my numbers in. 5 and 12. And so what we're going to do now is we are going to have a look at what these things squared are. So 13 squared is 169, 16 squared 256, 10 squared is 100, 22 squared is 484, 5 squared is 25, and 12 squared is 144. Okay, next thing we're going to do is we're going to add these up. So we get 13 plus 16 plus 10 plus 22 plus 5 plus 12, so that comes to 78. And in the other column I've got 169 plus 256 plus 100 plus 484 plus 25 plus 144 gives me 1178. Again, just for our context, what we've got in that column is the sum of x, and that one there, my sum of x squared. So I want to find my mean. So x bar is what we get when we add up all our things and divide by how many things were there. Sum of x divided by n. So I've got 78 divided by, in this case, 6, and so that gives me 13. So I've got my mean. Next, I need to find my standard deviation. So again, I'm going to use the same formula as I did last time. I've got the sum of x squared minus sum of x all squared divided by n all over n minus 1, and that is under the square root. So stick my numbers in. I've got 1178 minus 78 squared divided by 6 all over 6 minus 1, and that is where we are square rooting. So just like last time, I'm going to take this bit to the side, and I'm going to find 78 squared divided by 6. I'm going to try and tidy that bit up as much as I can. And so I've got 1178 minus, well, when I do that bit there, it gives me 1014 all over 6 minus 5. 6 minus 1 is 5, sorry. And at this point, once again, I can type my calculator. So I've got the square root of 1178 minus 1014 all over 5. That gives me 5.73. And so back over my question, and I've got my standard deviation. Part B, as it often does, would like me to make two valid comparisons comparing the waiting times. In our second part here, we've been introduced that Sophie, she's got the same internet provider, she's recorded the same things, and her mean is 15, and her standard deviation is 4.3. So we want to compare mean, we want to compare standard deviation. So in the first go, the one that we worked out, the mean was 13, standard deviation 5.73. In the second one, in this new case that Sophie's given us, we've got a mean of 15 and a standard deviation of 4.3. Okay, so we've got our first comment from the data. The first set of times, and who made those ones? They were Jack's. Where on average shorter. However, as the second set, they belong to Sophie's, had a smaller standard deviation. They were less spread out. And so I've got a comment on my mean and a comment on my standard deviation. And again, it's not enough to just say the mean is bigger or the standard deviation is smaller. You need to tell us that what you know is that you're looking at the first thing here is a measure of average, and the second thing here is a measure of spread.